We'll now take a look at the pound character, and this just simply represents any single digit that's 0 to 9. It's a single digit, which means it could be any digit 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So we're going to see some patterns that involve this particular pound symbol. So let's take a look at a couple of examples. So here we're going to see if 2016 is like pound, 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 pound. So what our pattern is saying is, does our string contain exactly 4 digits? If so, then it matches our pattern. Well, we have 2016, so sure enough, it does match our pattern, so this is going to be true. Let's try this example. Does this match our pattern? And the answer to that is no, because the problem here is we have the A in the third character. That is not a digit, so it does not match the 4 pound sign pattern. So this is going to be false. Now what about something like this? Does this work? And the answer to this is no. This is going to be false because our pattern is a single pound sign. That means our pattern is a single digit. Our string here has 4 digits, so it's not going to match our pattern, so this doesn't work. So let's try another example. Let's say we have A2 and see if that's like a pound. This is going to be true because our pattern is saying that the first character must be a capital A, and then the second character must be a digit 0 through 9. And we see here that our string does start with a capital A, and our second character is a digit. It's the digit 2, so this does match our pattern. So we're good here. Now what about this example here, where A2 is like 2 pound signs? This is going to be false, because even though the second characters are fine, the first characters are not. Our pattern says the first character must be a digit. But in our string, the first character is a capital A, which is not a digit. So this doesn't match the pattern, and it returns false. Let's try one more example. Let's say our string is P2P, and our pattern is question mark pound star. That sounds fun, isn't it? Well, let's look at what the pattern is saying to show, to explain why this is actually going to be true. The question mark, remember, means it can represent any character, but there has to be a character. So we see that we have a P as our first character, so we're good there. And then in our pattern, we have a pound sign, so that means the second character has to be a digit 0 through 9. And if we look at our string, we see that we do have a digit 2, so that part matches. And then our star in our pattern means that we can have 0 or more characters. Doesn't matter what they are, they can be any characters. So if we look at our string, we see that, yeah, we have a character, we have a P. That meets the star requirement. So sure enough, our string does match the pattern, and this returns true. The next component of our patterns is a little different. Here I called it character list with square braces, and I'll explain why in just a minute. Before we had the question mark character that allows us to match any character and we'll be good. This kind of takes it a step further. So the idea with this is that instead of matching any character, we can actually specify what characters would be part of the pattern. So what we would do is we would create a group of 1 or more characters in a set of square brackets or square braces, however you want to say it. And we can use this to match a single character in the string. So what we're just saying here is I can put in like 3 characters, and what I'm saying here is at this spot in my string, that the character can only be one of those 3 characters for it to match properly. Now you might be thinking, well, what if we have a large range of characters? Do I have to put every single one in there? Not necessarily. We can specify ranges in our character list by using a dash. So we'll take a look at some examples to help illustrate how to use this. So here we have the string ran, and look at our pattern. So here's what our pattern is saying. The first character must be a capital R. The second character can be a lowercase a or a lowercase u. We have the square braces or brackets, and then we have a and u in there, which means the second character can be a or u. That's what we're talking about here. And then the third character has to be a lowercase n. If our string matches that pattern, then the like operator is going to return true. So we see here we have the string ran. The first character is capital R. The second character is an A, which matches one of the characters in our list. and then the third character is a lowercase n, therefore this is going to be true. Let's try another example. Here we have the same pattern, but now we're comparing it with the string run. The first character is fine because it's a capital R. The second character is a U, which once again matches one of the characters in our list because it can be either A or U. The third character is an N, therefore this is going to give us true. Hopefully this makes sense so far. Now let's try run with the R being lowercase. And we see that this is going to be false because the first character is not a capital R. It's a lowercase r. So it does not match our pattern. Therefore, this is going to be false. Let's try this example. So here we changed our pattern just a little bit. Instead of saying that the second character has to be either A or U, we're using a range, A through Z. And this is saying any lowercase letter of the alphabet. So any lowercase letter from A to Z is valid for the second character. So we see, if we compare here, our first character is capital R. That matches our pattern. The second character is a lowercase u. So that's fine because that is part of our range from A to Z. And then our third character is N. That matches. So this is going to be true. Let's try another example. Here we're going to use wrong. So does that match our pattern? Well, we're fine with the capital R and the N. That part is good. The O is fine because, once again, that is part of our range here because we're saying any lowercase letter between A to Z is perfectly fine for the second character. So since O is part of that list, this is going to be true. Now, I should mention here that if we were using our other pattern where we had just AU, Ron would not match that pattern because O is not A or U. Let's do one more example. Here we're going to compare RAN with R and then the range A through Z. This is false. And the reason behind this is even though the R's match and the A matches the range of lowercase a to lowercase z, the pattern does not have anything for the third character. There is no third character in the pattern. So when we see that there's an N in our string, that does not match our pattern. We have to remember the range that we have here in square braces corresponds to a single character. If I wanted another character, a second character range, I would have to have another set of square braces and then put in my range in there. So this range that we have here is for one character, not any number of characters, and that's why this is going to be false.